Morning, everybody. It is the first day after our vacation break, and we are going to talk a little bit about chemistry. I got my chemistry shirt on, carbon-based life form. And so we're going to be talking about chemical changes. How do we know chemical changes occur? Some of this is review. And we are going to spend the remainder of the year. Normally in class, we are doing a lot of experiments this time of year. And sadly, us not being here. Hey, Trevor, glad you joined us. Sadly, not being here. Please say hi as you come in. I see we got 5 people here. And is that David we got too? And Lucas, awesome. So we're gonna get started. Hopefully some more people will join us. One of the things we did earlier in the year, we talked about how do we know if a chemical change has actually occurred. And I don't know if any of you guys remember some of the ways that we know that a chemical change has occurred. We came up with 6 things that we could identify that would let us know that a chemical change has occurred. Does anybody remember any of those things that might lead us to believe or understand that a chemical change has occurred? No, dead silence, tick tock, tick tock. All right, I'm going to give you one, and maybe it will spur you guys to think of some other things. One of the things that might happen is when we mix 2 chemicals, we might feel either heat or cold. And so what we're talking about is a temperature change. Sometimes you can mix chemicals and it'll cause a reaction that produces heat, or sometimes a reaction that gives off heat, and so the actual object itself becomes quite a bit colder. Can anybody think of anything else? Some of the other things that we've talked about over the course of the year. This is going way back to the fall, actually, which is why we're reviewing this. Keep this fresh in your head. So a change in temperature would be one, either hot or cold. How else might we know if a chemical change has occurred? How else might we know if a chemical change has occurred? Anybody get that hint I just gave you? Somebody type in there. First of all, what happens? Let's talk about something that we all know about. What happens when we mix baking soda and vinegar? What happens when we mix them? What do we see? Let's think about some of the things that we actually see when that happens. When we mix baking soda and vinegar, how do we know that that's a chemical reaction? Because what are some of the things that we see? Everybody's afraid to answer. You're afraid to give an answer. It's okay if you're wrong. It bubbles, that's right. Good job, Lucas. It bubbles or it explodes. And so, do we see it bubble? We see it bubble, right? We see those bubbles. And so that's another way that we know that a chemical reaction has occurred. Very good. What goes along with those bubbles? Do we sometimes hear things, especially if it explodes, right, Trevor? If it's something's exploding, heck yeah, we hear a sound. And so those are good. Those are two really good ones. It makes a sound. It can bubble. It can produce heat or cold. So those are three good things that we've identified. Anybody else know what I meant when I went like this? What did I mean by that? Because that's another one. Sometimes I might need to put on, I don't have them with me, some sort of glasses to protect my eyes. Yeah, it could smell, right? So not always bad, but a lot of times we associate a bad odor with a chemical reaction, but it doesn't necessarily have to smell bad. It's just an odor. So yeah, that's what I meant by that is, yeah, there's an odor. So we know that there's a chemical reaction. Sorry. When we sense a change in odor. And let's see, what example do we have of that? First of all, not to gross you out, but our bodies produce odors, unfortunately, and those are all a result of chemical reactions. When you sweat, that's actually a result of a chemical reaction. And so that's good. We've got bubbles. It can make a sound when it explodes. We've got an odor. We've got hot and cold. I can think of two other things. What usually goes along with most explosions? What else do we have with most explosions? Trevor, since you answered that, what else goes along with an explosion when you have something actually exploding? What else happens? Sound, loud sound, a vibration. What else goes along with it? Boom, when something explodes. What do we sound? Absolutely the sound. What do we see with our eyes? It's always good to think about our senses when we're talking about understanding when a chemical change occurs, because this has to do with observations. We're talking about labs. When we do labs, what do? We observe, right? We observe sounds, we observe visual changes. We use our sense of smell, our sense of sight, our hearing. On occasion, if we are allowed and told, we could use our sense of touch. Absolutely. Way to go, Lucas. That's a huge one. The colors can change. I remember I did an experiment, I think it was this year, where we mixed two chemicals and it went from a clear substance to purple. And that's how we knew that a chemical change had occurred. Simple change of color. So absolutely, if we have a color change, we can be pretty sure that a chemical change has occurred. And there's one last one that I was thinking of when it goes along with an explosion, and that is it usually creates light. Not all reactions create light. How do we see light? We see light as a flash or even a fire, but light. So we have Let's review what we talked about. Bubbles, color change, something that makes a sound, an odor. It could smell bad, it could smell good. A change in temperature, where it becomes hot, it becomes cold, or light. Can anybody think of anything else before we move on with that? So good job with that. Got some good answers there. That's awesome. I'm really happy with that. And let's go on to a couple other things. So there's going to be an assignment that I have to break apart that basically talks about chemical changes. And I have to, it'll take me a little bit to get it out because it's a multi-page thing, and I have to divide it up and only post 1 or 2 pages. But it basically has to do with what we've been talking about, which is physical or chemical changes. Let's separate what a chemical change is from what a physical change is. So let's talk about what the states of matter are. We basically talk about the 3 main states of matter. Does anybody know, can give me one of them? What are the states of matter? The states that matter exist. All this stuff that's around me, floating around in the air, is one state of matter. This tape measure is another state of matter. Anybody starting to remember now? I don't see any answers up there yet. And another state of matter. Gas, right. And so the air that's around us, Lucas, sometimes we say, oh, it's air, but it really is gas. Very good. Liquid. I try to give you guys hints, right? Liquids. So we got liquids and we got gas, and the third is solid. Excellent job. And so we have different states of matter. Remember this. Something can change its state of matter, and that's different than a chemical change. What will happen to this if I put it in the freezer? It's going to go from a liquid to a what? And I can also put it in a pan on the stove and heat it up, and all this liquid will eventually disappear. Well, I'm not a magician. It goes from a liquid to what? So I can put this in the freezer and it can become a solid. Very good. Or I can put it on the stove and heat it up and it becomes a what? Good job, David. What happens if I put it on the stove and heat it up? What's going to happen to the liquid? It's going to become what? What state? Remember, we got the 3 states. If we freeze it, it becomes a solid. If we heat it up, boil it, it becomes, somebody type it in there, a gas. That's right. Very good, both you guys. So don't confuse a change in state with a chemical change, because they're 2 different things. We can take a substance, change its state by changing its temperature, but it is still H2O. Whether it's a solid, liquid, or gas, it is still H2O. It doesn't change chemically, it's only changing its state. So got to be very sure that you know the difference between a physical change and a chemical change. What about when you leave a banana out? Anybody, most people like bananas. Anybody ever leave a banana peel sitting out? I actually have one in the other room that I left sitting out and I forgot to get it. I was going to bring it in here, but it's really ugly right now. It's jet black. And so it has started to deteriorate because it is actually undergoing a chemical change. And Mr. Fosnight and I, yeah, it goes bad, doesn't it? And it starts to rot. Well, Mr. Fosnight and I have both started to do something for our gardens. We'll take banana peels after we eat the bananas and put them in like a 2-liter container or any sort of big jug and let them sit there for a week or two. And all those minerals and nutrients that are in that banana peel start to go into the water, and we use it as fertilizer. And you, yeah, we don't want to slip on any banana peels either, especially a rotten one. So what's happening when you leave that banana out? It is actually a chemical change. It's reacting with the oxygen, which is a gas that's in the air. It's actually going through a process called oxidation. So that is a chemical change that's taking place. And we can see it. Number one, we could probably smell it after a while. Number two, what do we see? We see what color does that banana, it goes from, before it's ripe, it's green. When it becomes ripe, it becomes yellow. And then once it becomes rotten, what color does that banana peel become? Remember, that's one of the things is that color change. Yeah, if it turns black, throw it away and start over. You don't want to eat that, that's for sure. And Mr. Fosnight, how long? That's good. How long do you let your water ferment? That's not the right word. How long do you let your water, your banana water go before you use it? A couple weeks? We've already started using it. By the way, I know it helps that I'm home, but we have had the most success with our garden starts this year compared to any year so far. Anybody have any questions about anything that they've done over the past month? Yeah, 2 weeks is probably good too. I think that's probably about the average period of what I've used. And you can reuse that bottle, get rid of the old, if you can get the old bananas out. I found some of the juice bottles have a bigger spout on the top when you can get the bananas out. Not as easy with the 2-liter. But I know you guys have been on vacation, and it looks like the people who have joined me, I've gotten stuff turned in from most everybody. Does anybody have any trouble getting on Google Classroom? I will be posting an assignment this afternoon on Google Classroom about chemical and physical changes. Remember the difference between chemical and physical change. Physical change is a change in state. Chemical change means it switches. Here's an important Here's an important thing to remember. If I take water and I freeze it, that's a physical change. Can I reverse that? If it becomes ice and becomes solid, can I reverse that? I can reverse it by warming it up, right? And it melts. If it's a chemical change, most chemical changes, or virtually all chemical changes, are not reversible. Once that chemical change has happened, you can't undo it. Once that banana has rotted away, it can't be undone. That makes sense? And so that's one of the things that we know to look at when we're looking at a difference between chemical changes and changes of state. All right. Real quickly, I don't know if I showed some of the sixth graders. This is something that we planted a few weeks ago. And some of you guys might have seen this. This is called microgreens. This is actually something that you actually can add to a salad. You can eat it, just like lettuce. Okay, it's actually really good. 2 weeks, and it's about ready to harvest. That's crazy. How big should our project be? How many moons? You talking about your book? What book did you get? Your book project, what book did you get? While I'm waiting for him to answer, another idea I have for you guys, you want to do something nice and work ahead of time on a Mother's Day gift, or not everybody lives with their mom, I know that. If you live with an aunt or your grandmother or another relative, nice quick little gift you can do. Honestly, this pot is from the Dollar Tree. $1 for the pot, $1 for a little bag of soil, $1 for some seeds. You got some wildflower blend. You could do impatiens. You can do a wildflower blend that works good in the shade. These ones are pollinators. And for $3, you could make a nice little gift for somebody, whoever you want to make it for. If you're doing like a diorama, maybe the size of a shoebox. I'm not sure what the question is about how many moons, because everybody got something different, a different book in sixth grade if you're talking about your book project. Don't overdo it. Just make whatever you're doing, make it reasonable. If you can ask a better question, I can answer that a little bit better. And you're talking about the diorama. The size of a shoebox is fine. That's this big. You can use whatever. You can use paint, whatever material you have. So you got a book on the moon, it looks like. Okay. It doesn't need to be big. Try to be proportionate. The moon is about a quarter of the size of the Earth, roughly, and just try to have things in proportion. And a shoebox would be perfect, like I said. That would be a great size, and just do the best you can with what you got. I'm always excited to see some of these. They come out really cool. You never know what you'll find in your house that you can use. Look online for some ideas. That's fine. And I know I'm going to go pick some up that were already turned in tomorrow at school. And so just keep working on them. That's fine. Yeah, Mrs. Yangling is on, and she said she's had 2 that are turned in and that they're awesome. I'm excited to see those. I really am. So just shoebox big. The important thing is that whatever you produce, it represents what you learned in the book. What you learned in the book. Maybe it's something about the size of the moon, or the craters on the moon, or gravity, or anything that you learn that's associated with that book that you did would be fine. And the wonderful thing about doing the dioramas is a lot of it leaves up to your interpretation of what you learned. And sometimes something is really interesting to you, and you can focus on that, and that's cool. If you have any questions, at the top of this chat, you'll see my email, and you can email me. Some of you already have. Are you going to do the moon phases? Oh, that would be cool. You don't need to do 30 or 28. There's 28. You can do new moon, first quarter, full moon, third quarter. So basically, you're talking about 4 phases of the moons would be fine. Does that help you answer that question? That should be fine. And it would be cool if we had an understanding of where it is in comparison to the Earth and the Sun. So that would be helpful. And I hope that answers your question. I got to get off here because actually, I'm going to end this and be streaming again for the 8th graders in just a minute. If you have any questions, please don't hesitate to email me and we'll get through it. And I will be back on with the 8th graders in just a minute. So, say goodbye to Harold. Bye, Harold. All right, take care.